So today we're going to dive into a story that is just incredible. It connects a 2,500-year-old text from ancient India directly to the cutting edge of artificial intelligence. It sounds impossible, but it turns out there's an ancient code that's helping us solve a very, very modern problem.
Okay, let's get right into it. Think about this. You ask your phone or your smart speaker to understand you every single day. But teaching a machine to actually get language, it's unbelievably hard. Our language is just this beautiful mess of exceptions and weird rules and all this nuance. Computer scientists have been wrestling with this problem for decades.
And that's where this story takes a fascinating turn. What if the key to solving this wasn't some brand new algorithm cooked up in a lab, but a really, really old one? An approach so elegant and so sophisticated that we're only now, in the age of AI, starting to fully appreciate its genius.
To get our heads around this, we have to go way back. We're talking 5th century BCE, to a grammarian named Pāṇini and his masterpiece, the Ashtadhyayi. Now, you've got to forget everything you learned in school about grammar books. This isn't a book. It's a language-generating machine. It's an algorithm for building the Sanskrit language from the ground up.
So this machine, the Ashtadhyayi, is built on a set of about 4,000 rules, or what are called sutras. And each sutra is incredibly short and precise, almost like a single, powerful line of computer code. And together, they form this complete, totally formal system for generating every single valid word in Sanskrit. The core process here, the way this machine runs, is called derivation. It's pretty straightforward, actually. You start with the basic building blocks, a root word and some affixes, and then you start applying Pāṇini's rules in a very specific order. It's this purely mechanical, step-by-step process that builds a perfect word from its parts, kind of like a factory assembly line for language. Okay, but wait a second. 4,000 rules? How does a system like that not just collapse into total chaos? This right here is where the real genius is. Pāṇini's algorithm has its own logic built right in to manage itself. It's incredibly elegant. The system knows exactly which rule to apply and when.
And the logic is something modern programmers will recognize immediately. It's basically an if-then-else statement. Pāṇini organized his rules into general rules, called utsarga, and then exception rules, called apavada. And here's the key. The exception rule always wins. It overrides the general rule in specific situations, basically carving out its own little territory.
This quote really explains why that kind of precision is so vital. You know, a grammar rule can't just be a blunt instrument applying everywhere. It has to be carefully controlled and restrained. Otherwise, it's just going to start generating all sorts of incorrect, nonsense words. And this system of exceptions is what provides that crucial control. So let's actually see this thing in action. Let's say we want to create the word for servant, which is bhartya. The machine starts with the basic stem and a suffix. Then, bam, the rules kick in, one after another. A rule comes along and changes the final S into an R. Then another rule comes in and transforms that R into the final H. You see, each step is a direct, logical transformation, all guided by the system's code. And get this, it gets even more sophisticated. Pāṇini built in this principle called asitattva. You can think of it as an order of operations, just like in math. It decides which rules are invisible to other rules, which completely prevents conflicts. It makes sure that for any word you want to build, there is only one correct path and one correct final answer. The whole system is completely self-regulating. It's amazing.
Okay, so this is all incredibly impressive for Sanskrit, no question. But it raises a huge question, doesn't it? Is this just a one-trick pony, a brilliant system that only works for one language? Or are the computational principles underneath it all universal? Could this machine's logic actually be applied to other languages? So to really put this to the test, researchers tried something pretty ambitious. They took one of Pāṇini's core techniques for organizing sounds and tried to apply it to a language that's completely different, German. I mean, this is the ultimate stress test of its underlying logic.
And the results were, well, they were remarkable. Pāṇini's method for neatly grouping sounds, this technique called pratyahara, it worked perfectly for describing the sound classes of German. Yeah, the specific sounds are totally different, but the computational method, the logic of defining a group with a start and end marker, it worked flawlessly. This was the proof. The logic behind the machine is truly universal.
So where does that leave us today?
I mean, it's one thing to know this system is universal, but is anyone actually using it? The answer is a huge yes. These ancient Pāṇinian principles are actually being built into modern software right now.
Believe it or not, this ancient logic is running on modern hardware as we speak. It's the engine behind all sorts of tools, everything from helping with text-to-speech synthesis to complex syntactic parsers that help a machine understand sentence structure. It's even being used in algorithms that help figure out what a word means when it has multiple definitions.
One of the coolest applications, I think, is how it deals with Sanskrit compound words. In Sanskrit, you can just keep sticking words together into these massive chains that can literally go on for pages. It's wild. But by computationally reversing Pāṇini's rules for making words, these new tools can perfectly break them back down into their original parts. And that's absolutely essential for anyone trying to understand these texts.
So, when you step back and look at the whole picture, what's the big takeaway here? Pāṇini wasn't just some ancient grammarian. He was one of history's great systems thinkers. His Ashtadhyayi is this incredible monument to human logic, a perfect self-contained system that basically anticipated the core ideas of computer science by 2,500 years.
And this quote here really gets to the heart of it all. The goal was always to synthesize utterances out of constituent units. Think about that. Taking basic units and using a set of formal rules to create a complex output. That is the very essence of what a computer program does.
This whole story just leaves you with this one, final, kind of mind-bending thought. Pāṇini's grammar was hiding in plain sight as one of the most powerful algorithms ever created. It just makes you wonder, right? What other ancient systems of knowledge, in philosophy, in music, in logic, are just sitting there, waiting for us to see them not as relics of the past, but as powerful blueprints for our future?